shut off your camera. But let us know if you have concern with that. We just think it's something we can all use at a later time to reference what's said tonight. One other thing, now that we're starting, if you're not doing a presentation, we would urge you to mute yourself, just in case. If you're like me, we have a dog that we're trying to suppress right now and things like that. So it's good to mute if at all possible. And lastly, with questions, we welcome questions. We think we have plenty of time for questions after the presentations are over, but we were going to have our presentations first and then open it to questions. And if you're familiar with Zoom, you probably already know that you can enter questions at any time on chat. If you think you're going to forget the question you want for the first presenter, write it out in chat or make a note of it. And after we're done, we will go over the questions that were submitted in chat, and we'll also it'll be okay at that point to just, if you want to do it orally through Zoom, that's fine. I think with those preliminaries out of the way, maybe I should do a really brief introduction of our presenters, who we really appreciate them giving us their time. You may know that no one gets paid for this, so they're really very generous to come together and share their expertise with us. I think in the order of the presentations, it'll first of all be Dr. Anthony Faig, Professor of Geography and Environmental Studies at Central Michigan University. Tonight, he'll be talking about ways of thinking about public schools and environmental education policy, related to climate. How do our kids learn about these things? And then Dr. Daria Kluver, who is an associate professor of climatology in the Department of Earth and Atmospheric Sciences at CMU and a member of CMU's Institute for Great Lakes Research. She teaches a wide range of meteorology and environmental science courses. Her research areas include hydroclimate monitoring of the Great Lakes region, large-scale climate impacts on North American snowfall, is very relevant for our lawn right now, and regional climate modeling of precipitation. Her presentation today will look at how climate change impacts the frequency of extreme temperature events in the United States. And finally, Murray Borrello, Director and Chair of the Program of Environmental Studies and also Professor of Geology at Alma College, will present. He also, by the way, is an appointee on the Environmental Permit Review Commission for the state of Michigan, and was past director of the Center for Responsible Leadership at Alma. And Murray has three of his students joining in two parts of the presentation. First, Hannah Stifler will be talking about climate psychology, why some people don't believe and others are depressed. And then Kathleen Kreisnagel and Abby Pataki are doing climate change and environmental justice. How will our future climate impact poor and minority populations? And so I guess with those introduction, I guess Anthony Faig is going to go first. I will not come in the middle of the other presentations. We'll just transition from one presentation to the next. So thank you, all of you, for coming.
All right. So I've gone to a lot of these forums, and this is the first time I've presented at one. So this is very exciting, and I want to thank you all for letting me come here. All right. You should be hearing me, I hope, and you should be seeing a slide, and you should be seeing me. Is that happening?
Yep. Also.
All right. Okay. All right. So my area of scholarship, one of them anyway, is environmental education policy. And so that's what I want to talk about tonight. And what I really want to do is I want to ask the big question, which is this: how do we educate in and about a changing climate? So we live in frightening and magical and frustrating times in terms of Earth environment. We know why it's frightening, but it's magical because our scientific knowledge is growing so much and so fast. And it's frustrating because Earth systems are hard to teach about. And we're not really set up in our current educational policy world in our nation to really do it effectively. So how did we get to where we are today? If we talk about how we're going to educate for climate and environment, then it helps to understand where we are now. And to understand that, we need to take a field trip and go to Texas. Now, I know you're thinking this is Reid-Knox, we should be talking about Michigan, but the current educational landscape we're in now was grown in and exported from Texas. And by the way, that image up there is by the Chippewa River here in Isabella County. Okay, so on our way to Texas, let's ask this question, which is, what is education for in like the big sense? So there's a lot of different ways we can answer this, and they don't have to be, there isn't just one answer, but we tend to think about education as a public good in the context of economics. So how do we solve economic problems? We see schools as economic drivers, and we use them to train a workforce and to train informed consumers. Okay, so with that in mind, when it comes to understanding where we are today, we got to go back not only to Texas, but back in time to the 1980s and 90s, to the work of H. Ross Perot. You might remember him and the Texas Business Roundtable, because they really shaped where we're at today, which I call the Texification of education. And that culminated in 2001 with the No Child Left Behind Act, okay, signed into law by George W. Bush, 2001. So what was that all about? Okay, so this was educational policy that was driven by the notion of accountability, and that expressed in the form of wide, large-scale, high-stakes testing of students with sanctions and rewards associated with those for teachers and schools. The science education in that regime, certainly early on, was facts-based. Now, we talk about facts, we think, okay, facts are good. We like facts better than falsehoods. But what isn't ideal is the memorization of science facts for the repeat on the science test, okay? And that leads to a common complaint, lamentation by educators, which is if something ain't tested, it ain't taught, okay? Now, one thing Texas did not export entirely anyway was the way that they exclude educators from the process of devising educational standards. Those are not written by teachers, those are written by legislators, state legislators. Now, that brings to mind an old expression, which is those who can teach and those who cannot make rules about teaching, okay? So fast forward to 2009, the person that you see in the background there is Arne Duncan, Secretary of Education at that time. And we see some tweaking of No Child Left Behind in the form of Race to the Top, which included grants and for schools and districts, and more collection of metrics and achievement data and accountability data. Which leads to ask, okay, where are we at now? What has happened in the last 4 years to grow and promote and develop the science education landscape? Okay, so as an educator, as a parent, as a scientist, as a person, I ask, it leads me to ask, and probably you too in our educational regime, what's missing? What's missing from this that would help us educate in a changing environment? Well, how about a sense of wonder? And I also want to introduce this concept of literacy. I'm going to talk about literacy differently than the way we're used to thinking about literacy. So let's unpack that. In order to form reasonable and working education policy, we need to think, and we want to apply that to the environment. We want to think about, well, how do we think about the environment? And there's no one way to do it. In fact, more ways are better. And we can start with a standards-based way of thinking about the environment. What do we need to teach? What do students need to learn and when do we teach it and as they progress through school. We can think about environment in terms of skills, as in what would you need to enter the green energy workforce? What do you need for bench science, or what do you need for craft and policy? There's crisis-based way of thinking about the environment, which we are in now and doing. And then there's literacy. And let's unpack that. And let's talk about that in this term, which I call eco-literacy. Okay. And I'm going to propose that environmental earth systems education ought to be driven by, built on the foundation of this eco-literacy. Well, what is that? Okay. Take this, take environmentalism, and it's a big, big thing. Environmentalism is a giant category, but add to that the basic tools that people need to survive in a modern world. We'll call that cultural literacy. And then what we normally think of when we think of scientific literacy. Okay, so that's the paradigm. Now, what I'm going to do is say that this paradigm, as applied to educational policy in K-12 and beyond, needs to be built on 4 basic themes. And I'm going to talk about those one at a time here. But the bottom line is this: effective earth environment education requires us to get out of our enclosed spaces, whether those are mental or physical or metaphorical. Okay, so what's the first theme of eco-literacy? Well, that would be this: viewing the earth as a set of living interconnected systems: land, interior, sky, air, water, life, humans. Okay. And let's talk about the second theme, and that is a really big one, and it's called deep time. Okay, what is that? Well, take a look at this picture here. This is a picture from West Texas. It's a high altitude desert, and it's surrounded by rather tall mountains. So let's take a picture of the same place, but back in time. The time difference between this picture and the previous one is about 180 million years. Okay. That used to look like this. Okay. So the rocks that you see in the mountains in the background there, this is the environment they form in. Okay. So deep time means a foundation. That foundation means that acknowledging and teaching that earth processes take place and timescales that are way bigger than human timescales. But more important than that is the willingness of the learner, of the teacher, of the policymaker to acknowledge that fact. Okay, so that's the deep time theme. The third theme of eco-literacy is environmental justice. Okay, and that is asking the question, which is, who pays for environmental degradation? Who bears the cost of climate change? Where is power located? And who has it and who does it? Who doesn't? And how do we act on that? How do we ensure an environment that is equitable, where all people can flourish and all people can participate in the care of that environment? And I also want to point out this man. Dr. Bullard is widely considered to be the father of the environmental justice movement. And I urge you to check out some of his work. He's required reading in my environmental justice class. So that leads us to our fourth theme of eco-literacy, and that is that of stewardship. Okay, so teaching to not just facts and figures and understanding of processes, but also injecting a sense of care, custodianship as a curricular value, as a policy value. Okay, and that means teaching deliberately to cultivate a sense of wonder. So as a side anecdote here, when we teach children about the environment, research has shown that children aren't prepared to think about environmental crises until sometime after 4th grade. And the time the time they spend in school before that should be focused on really cultivating that sense of wonder in order to really appreciate and tackle the crises that they're going to be studying later on. Okay, so if we're going to say that we want to use this way of thinking, use eco-literacy as a foundation for national educational policy, there are a couple of caveats and things that we got to keep in mind. First of all, we do want to assess how education is going, and we want to make sure we're doing it effectively, and we want to improve when we can. And so that means that certain things are going to be hard to measure. Like, for example, what ruler do you use when you want to assess a child's sense of wonder, if you believe that is an important part of a curriculum? Okay, so what we need to do is we need to revision what accountability and assessment looks like on a national scale. Now, COVID has disrupted everything in education. But there is an opportunity here, and that is that, first of all, we are probably going to be working with smaller class sizes, or the need for smaller class sizes, for some time to come. And that means we also have an opportunity to reimagine what the school calendar might look like and how we use those facilities. And then what that means is we also have a chance to reimagine accountability. So in all of these multiple crises, the fact that they are happening at the same time gives us an opportunity to rethink how we do Earth environment education. And that's what I'm going to leave you with, that little bit of hope. So I want to thank you for your attention and listening to me. I appreciate it. And over to you, Ed and David.
Do we have Daria up next? I think you can take it away. Ed, was that the order?
Yes, I'm just working on sharing my screen. Hold on, it says Zoom doesn't want to share my screen. Of course. I have to give it permission. Oops. I'm sorry, I have to leave the meeting and then come back in. I'll be right back.
So we do at CMU, we do our work meetings through Microsoft or through WebEx, and then I teach through Microsoft Teams, and then everything else is Zoom. And every one of them shows your camera differently too.
They all provide unique challenges and opportunities.
Yeah.
That's a very mild way to refer to our problems.
Very diplomatic.
Yeah.
Okay, I believe I'm sharing my screen now.
Yep.
Sorry about that. This would be a great example of what my semester has been like, teaching both online and in person at all times. Things that had been working all of a sudden stop working. So that's just a window into my life. All right, thank you so much for that that talk, Anthony. That really has me thinking. And you were kind of talking about how we deal with crises, and that is a beautiful segue into my talk, unfortunately. And I was originally asked to come talk about climate, and so I was going to talk about Michigan climate, and then last week happened. And we had such an interesting and devastating weather week last week that I thought it was probably important to talk about what is the connection between the things that happened last week and climate change. And the connection here is in the jet stream and the polar vortex. And so that's what I'm going to be talking to you about today. So this is what we had last week. And these are maximum temperature anomalies. And an anomaly is a departure from average. So in this case, all of these dark blues are temperatures that are around 40 degrees colder than normal. So this is from last Monday. And you can see these striking temperature anomalies down the entire center of the continental US. No? Okay. So I went and grabbed some data, just a couple here. So this one is from Austin, and this is showing the average climate conditions, and then overlaid on top is what we experienced last week. So this is temperature on the y-axis here, and months on the x-axis. Green would be average conditions. The blue, the bottom of each blue line is the record cold temperature on that particular day. And the top of the red line is the record warm temperature for that particular day. And then in the dark gray here, that's what was observed this year so far. So you can see that in Austin, Texas, they were in pretty well average to above average temperatures. And then we hit this last week. And you all probably know that, especially in the South, records were broken for coldest temperatures on the 15th and the 16th. So I grabbed another one. I mean, I could have shown you dozens of these. This one is from Houston. Same thing again. Here are normal conditions. Here are record cold. And then you can see we actually broke some records in Houston. So this is what happened last week. And I grabbed a few snapshots from the National Weather Service offices that just listed some of the cold temperatures that we broke. And some of these are pretty amazing when you look back. The Houston, Texas record, this is from February 15th, that coldest temperature was set in 1905. And so that's the record that we broke this last week. But you can see we broke records all throughout the whole central part of the US. So of course, the news was about the southern tier because they aren't used to these sorts of conditions. But this was really a very widespread cold weather event. And then here's from the 16th, because we had two very, very cold days. And you can see we had more areas. Corpus Christi, the old record was set in 1895. So this is going back to, you know, some of the earliest records that we have. And now they've broken that record. So this is what happened. And this was, I'm sure if you saw the news, you saw how devastating this was, particularly to the areas in the South where in Michigan, we know what to do when it's that cold. But in the South, I'm a military brat. I've lived all over in the South. I can tell you, before I moved north, we don't know what to do with snow and ice. They don't own plows. So you might be wondering, yes, it was really cold. So why are you talking to us about climate change and global warming? Well, take a look at this figure. This is 2019's temperature anomalies. So again, that's the departure from average temperatures. And this is showing for the globe. So you can see these kind of orangish and then reddish colors are warmer than normal. And this is the anomaly compared to the 1979 to 2000 average. And then the blue colors are where we're colder than normal. So this figure shows something that in climate science we call Arctic amplification. So this is the observation that the Arctic is warming more than twice as fast as the rest of the world. And you can see this pretty clearly here in this map. And there's other evidence besides just looking at temperature records. We can look at the extent of Northern Hemisphere sea ice. So I grabbed the most recent sea ice map, and this time series shows sea ice extent in millions of kilometers squared. And this is the July extent. And this represents when we would reach our smallest extent in the summer when we've been melting. And you can see this steady decline. And so this is some additional evidence to corroborate what we're seeing with this Arctic amplification or this warming in the Arctic. So why is this happening? The key here is the sea ice that we have in the Arctic. So ice and snow reflects incoming radiation from the sun very well. It reflects about 90% of the energy that hits it. So it's like we have this beautiful mirror on the top of our globe reflecting away energy. Well, if you look kind of down here on the left side of the picture, there's a little bit of open ocean here. And you notice that the color of this ocean is very dark. And so depending on the angle that the sunlight hits it, it can absorb a lot of energy from the sun. This, in some cases, depending on the angle, can absorb as much as 90% of the energy that hits it. So when we have warming here, we're going from a surface that reflects 90% to a surface that can absorb 90% of the energy. So once you get a little bit of melting, you see here that it amplifies. So this is really the key to this Arctic amplification signal that we see. Okay, so what does Arctic amplification have to do with this extreme cold temperature in the US? Well, there are two main ways that we think the changing conditions in the Arctic influence patterns in the mid-latitudes. That's where we live. The first is a reduced temperature gradient between the poles and the equator. So first, I have to define the jet stream, because the jet stream is a big player in all of this. So the jet stream is basically like a river of fast-moving air. And you can see it here in the diagram. The orange and red colors are faster-moving winds. And you can see that it circumnavigates the pole. And it can be very wavy, or it can be kind of west to east, sort of straight. And the jet stream separates the cold air masses to the north of the jet stream from the warm air masses that are to the south of the jet stream. Okay, so this is really important, what the jet stream is doing here. Okay, so there's another thing. If we change the temperature gradient, that's the change in temperature between the pole and the equator, it affects the jet stream. Now, I'm a very visual person, and I like to draw pictures. Ask any of my students, I'm always sketching them diagrams. So I actually recorded one earlier this afternoon and just put it in here, because I thought if I tried to do this live, I'm sure something would, go wrong. So let me start this, and then I'll just talk you through it. Okay, I kind of want to sketch for you what a large temperature gradient would look like. Now, in the atmosphere, warm air molecules are more spread out. So if you have a column of air that's warm, it's actually going to extend farther up into the atmosphere. Cold air molecules are more densely packed. So a column of the same amount of molecules will be shorter if it's cold. So if on the left we have warm air at the equator, and on the right we have cold air at the poles, the black line here is the winds at the top of the troposphere are going to head on the steep gradient. And then that arrow is the jet stream, and it's supposed to be coming out of the screen towards you. So with a strong temperature gradient, we have a strong jet stream that moves quickly, and it moves more or less from west to east. So here I sketched a very rough continental US, pretend like that looks like the US. And then here in the blue, this is a very strong, very fast moving jet stream. It's never this perfectly west to east, but just so you can kind of see. And it separates the cold air masses to the north and the warm air masses to the south. Okay, so this is with a strong temperature gradient. Now, what happens when we warm the poles? So now this air warms up a little bit. So it's a little bit more spread out. And the temperature gradient between the equator and the poles is going to be less steep. So that means our winds aren't going to move as fast. And the temperature at the equator doesn't change that much, because we're still getting roughly the same amount of solar radiation. So in this case, we're going to have slower air. We're going to have a weaker jet stream. And with a weaker jet stream, it becomes, it meanders more. So it becomes more wavy. So I kind of sketched this, and the troughs and the ridges don't have to be in those positions. I was just kind of sketching where they might be, but you can see we're still separating the cold air masses to the north and the warm air masses to the south. Okay, so if we're reducing that temperature gradient, we have this more wavy, weaker jet stream. The second way that the Arctic can impact what's happening here is through the polar vortex. So you've probably heard the word polar vortex, I'm sure. So let's go over what it actually is. So in this diagram, the polar vortex is up here on the top. So it's a pool of very fast moving, very cold air, and it's up in the stratosphere. The stratosphere is the layer above the troposphere. The troposphere is the bottom layer of the atmosphere where all the weather happens. And then the stratosphere is the layer on top of that. So this is way up there. This is like 30,000 feet above the surface. Okay, and it's rotating up there all the time, but it becomes much stronger during the northern hemispheric winter because it's dark, and so that air is colder. So it's very cold and it's very dense. I have another figure here. This is showing the wind. It's color coded for wind speed, and these are in kilometers per hour. And this is looking down from the North Pole, kind of at the Arctic, and you can see the polar vortex there. And these wind speeds are as high as 360 kilometers per hour. We're talking about around 200 miles per hour. So very fast winds, very, very cold, very dense air, but it's up in the stratosphere. So I like to think about it like pizza. I mean, who doesn't like to think about pizza? So the polar vortex is like, you know, when you're making pizza dough and you throw it up and spin it? Not that I've ever successfully done that, but if I had, imagine you've got your pizza dough and you spin it and it's up above your head and it's spinning really fast. Okay, that's what the polar vortex is like, this beautiful spinning pizza dough up in the stratosphere. Okay, hold on to that thought because we'll come back to it. So let's see. On the left here, this is what I've just described for you. Our normal polar vortex, it's up in the stratosphere, it's spinning, it's very, very cold, very dense air. And then we have our jet stream here, which I already described to you. The jet stream, we know about the jet stream that, you know, dictates what our weather's like here in Michigan all the time. Well, we can have all sorts of things that disrupt that polar vortex that's spinning up in the stratosphere. These are things like very wavy, deep troughs and ridges. We can have unusually large snowpacks over Siberia, large areas where we have open ocean and more moisture available. Lots of things can transfer energy and heat from the troposphere up into the stratosphere. When it does that, it can slow down or disrupt that polar vortex. So think about your spinning pizza, and what if somebody stuck their hand up there and poked it while it was spinning? It would get all wobbly, and then what would happen? It would fall down, right? So that's basically what happens with the polar vortex, is it's spinning and there's some disruption from the troposphere. It slows down and it kind of collapses and it sinks back down toward the surface. And so that's what's in the picture here on the right, is we have our weakened polar vortex, and then this very dense, very cold polar air sinks down to the surface and starts to spread out. And so here you can see our very wavy jet stream that we already said that's connected to what's going on in the Arctic. And then if we have our polar vortex that's descended, then the cold air masses that are coming south are really, really cold air masses. So I went back and I grabbed the jet stream map for February 15th, and you can see this is called a trough, where we have a dip in the jet stream, and we had an event where a polar vortex collapsed and sunk down. So this was all polar vortex air moving south, and the jet stream dipped very far south, so that's why that air was able to get all the way down to Texas, but we were breaking records all throughout the central part of the US.
Mm-hmm.
Okay, but just because we have a greater chance of a wavy jet stream, and we can get extreme cold when we have a polar vortex collapse, does not mean that global warming or climate change is no longer happening. Okay, this just means that because of the warming in the Arctic, the wavy jet stream is more likely to happen. There's a higher probability for it to happen. So this is one of the reasons why we prefer the term climate change, because one of the hallmarks of a warming world is more extremes, and these extremes happening more frequently. So I went and grabbed the 2020 temperature anomaly. So this is for the whole globe. For each of these pixels, they took the temperature anomaly compared to the average. So the yellows and reds are where we're warmer than average, and the blues are where we're cooler than average. So you can see that last year, we had a lot of warming in the Arctic especially, and then we had a minimal amount of warming most other places. 2020 actually tied with 2016 for the warmest year on record. So even though we've had these extreme events, overall, the globe as a whole is still warming. And this is data from NASA. Please go check it out. They have all the maps up there. And so I also grabbed the freeze trend. So these are the number of days where we have sea ice in the Arctic. And this is the trend, so the change over time from 1979 to 2019. And anywhere where it's blue, which I actually don't think we have any, we're getting more freezing. And anywhere where it's yellow and red, we have fewer days with frozen ice. So you can see the red colors in here are 25 days fewer per decade with freezing. So this is an ongoing challenge, and so Arctic amplification is going to continue to be a thing. That's not going away. And so I would like to leave you with this animation. And this shows the seasonal cycle in global temperature anomalies for every month since 1880. And they're color-coded for the years. And they kind of stack them up so you can get a sense of what our global temperatures look like throughout the entire year, instead of just looking at one number.
Oh.
And with that, I would like to thank you guys for your attention and thank you for coming tonight. And I would be happy to answer any questions you might have after the final talks. Thank you.
Am I on?
Yep.
Okay, I didn't know if we had other transitions. This is Murray Borello. Ed had introduced me, but I'm not actually going to talk because you just heard from the experts. But I thought Ed had invited me to participate, and I thought it would be kind of interesting to have a couple of presentations for students that were studying two different areas of the impact of climate change. And Daria and Anthony covered this brilliantly. And one is in the relation between climate change and psychology. And with that, I want to introduce hopefully our neuroscientist at Alma College, Natasha Swalv. Dr. Swalv is joining me with an independent study with Hannah, who's going to talk in just a second. And then the second, and so I'm introducing her because any questions are going to her. And then I'm doing a seminar on environmental justice and climate change. And I have two students, Abby and Kathleen, who will give just a real quick presentation. These are 5-6 minute presentations, and all they want to do is bring to light some really interesting concepts for you all that hopefully will generate some discussion. So with that, I'm going to turn to Hannah, who I see is on. You can,
I am here.
there you are. And this is Hannah Stifler, and I will shut up and let her talk.
So I'm gonna just kind of talk rather than give a presentation. So I hope that works for everyone. But like Dr. Borello had said, I am Hannah Stifler, and I'm a second year at Alma College. I want to begin by saying thank you for inviting me here to present today. But this semester, my independent study research is about the intersection of people's responsive behavior in the face of environmental issues such as climate change. So to begin, I want to talk about the processes in which we're able to process information. So one being the rational side of our brain or the cognitive side. So an example of this is by stating facts like the temperature of the earth is determined by greenhouse gases, or that the average temperature has increased by 1 degree Celsius in the past century. And the other way in which we process information is the emotional side of our brain, which tends to favor the emotions of anxiety and fear. So an example of this is by stating, in the year 2100, sea levels are estimated to rise anywhere between 8 to 20 inches above our current levels, which is a result from melting glaciers and expansion of water due to increase in temperature. So this will affect access to quality water and resulting in uninhabitable land. So this kind of brings fear. So this is hard for our emotional brain to process uncertainty with long-term threats that are brought about by climate change. So our rational side of our brain tries to interfere with the emotional side in order to distance ourselves from that threat and to kind of relieve that anxiety and fear. And in turn, we look for information or data to satisfy the emotional and rational sides of our brain. So to follow this, we look for information that supports our claims rather than rejecting it, and interpreting the information to suit existing beliefs is known as confirmation bias. So we see the use of confirmation bias on a regular basis. The best example of this is probably social media. So social media such as Facebook tends to show like-minded thinkers on one's feed. So however, this is, if you see a post with opposing views, you're more likely to kind of discard that information rather than obtain it, which is just for us to maintain our cognitive consistency. And when we find a post that fits into our existing beliefs, we automatically buy into it. And this also fits into the self-categorization theory. This is when people tend to seek closeness with people similar to themselves. So we seek to establish favor with groups not like us, but those who we want to be associated with. So on Facebook, you guys may see people who have left discussions, or maybe you've removed friends that you don't agree with because of the tenor of the discussion. And this leads to more of a focus on groups who think just like themselves. So in turn, we have groups that are favoring and praising each other and learning nothing outside of their comfort zone. So due to confirmation bias, individuals are looking for the information about climate change, but if it doesn't fit within their current schema, they kind of disregard that information. So an example of this is people who already have established views opposing climate change. They are less likely to seek information that will change their minds. However, if we start to remove these biases to a certain degree, we will be able to communicate about climate change more effectively. And the future effects of climate change are difficult for us to internalize because of the emotional side of our brain. And since we can't see climate change outside of natural disasters, our rational brain tries to kind of downplay the catastrophe. Those who experience the more immediate dangers of climate change are less likely to continue environmental action. So people on the East Coast who experience hurricanes, or in the South with tornadoes, they are less likely to continue those actions with climate change because of that immediate natural disaster. However, for those who do not experience such natural disasters like us in Michigan, we will begin to see more of the societal impacts of climate change. So for example, there has been a direct correlation between an increase in temperature and violence. And this is called the heat effect, which refers to the increase in aggressive behavior when temperatures increase, and therefore leading to an increase in violence and crime. Another societal impact of climate change is displacement and relocation of people. And as we have heard, in 2030, just under half of the world's population is estimated to live in countries with insufficient access to water. So by the end of the century, there is an estimated 200 million environmental refugees around the world. So the question is, where will these people go and how will this affect them? So since there is an emotional attachment to the places we live, and for those who have a strong place or national identity, this may lead to an increase in grief or anxiety or sense of loss. And these feelings can intensify the desire to go back to their natural state. So yet again, our emotional side of our brain intensifies with relocation, and then our rational side of our brain longs for the things that we want to go back to. And when people are forced to relocate due to climate change, they tend to question, what will the government do to help us? And when the government fails to properly protect those against natural disasters and the overall effects of climate change, people will lose trust and confidence in the system, which will result in backlash. So in order for the government to gain the trust of its citizens, they need to respond to climate change in a more proactive way rather than reactive. And a good example of this is the legislator in Texas has ignored the realities of climate change for some time now. And with the self-categorization theory, it tends to be hard for people to go outside of their individualistic behavior and actions towards climate change. However, Texas and Texans have been seeing currently firsthand experiences with natural disasters and the effects of climate change and how they truly are, along with the reaction of politicians like Ted Cruz. So this brings me to my final point. Understanding the psychology of people and how they take in, process, and behave in relation to climate change will help us educate the people that deny it, but also counsel those who internalize the reality of it. So that's it. Thank you, guys.
All right. And then finally, we have Abby and Kathleen, and they're going to introduce the idea of just cover briefly the idea of environmental justice and how it's linked to climate.
All right. Hello, everyone. Can you hear me fine? Yep. Awesome. Okay. So like Dr. Borrello said, that we will be talking about the link between climate change and environmental justice. Brief intro, both of us. I am a junior at Elma College studying biology, but I also have an interest in environmental studies, which led me here. And Abby, you can go ahead.
I'm a sophomore at Elma College and I am studying environmental studies.
Yeah, and I believe I can share my screen too.
Should be able to, yeah.
All right. Everyone was able to do this fairly easily, so I feel like I should be able to too. How do I do that?
Should be at the bottom. Share screen, green button next to like chat participants.
Right in the middle in front of my face, right? Perfect. All right, so the link between climate change and environmental justice. All right, so what is environmental justice? Environmental justice is a fair treatment of all people, regardless of race, income, or national origin, with regards to the development and implication of environmental laws and regulations, as well as the enforcement of these laws and regulations. And in simpler terms, environmental justice makes the claim that no environmental law or regulation should favor one single group over another, and the two similarities between this and basically the takeaway is the equality and fairness of all. An example of an environmental justice right here in Michigan is the Flint water crisis. And what had happened was the Flint's water supply was switched from a Detroit Water Department line to the Flint River. And the results of this were the water flowing through the pipes, which had been corroded, led to an increase of lead levels. And the water, this is basically covering everything that the people of Flint were drinking, cooking with, and bathing in. All right. What did these results lead to? The exposure to lead had both long and short-term effects to the people. And who was more affected? The more expensive, newer communities of Flint had newer, clean pipes, and the cheaper communities, which held the poorer population, had the corroded pipes and heightened levels of lead. What was done Originally, not much was done, and it took a lot to get people and other organizations to look into these heightened levels of lead. And overall, the people didn't have the resources that gave them what they need to look for help and to obtain that help. All right, what we can expect. Many people don't realize that climate change affects people of the minority populations as well as the poor disproportionately compared to other populations. And here we have the Environmental Law and Policy Center issued this report that assessed the impacts of climate change and what it has on the Great Lakes. The report shows us what we can expect to see in environmental and biological terms, but can also give us insight to some of the environmental justice challenges that can also be faced in the future as climate change progresses. And over here, I listed some of the things that they targeted, like air temperature increases, heavy precipitation, water quality, agriculture, irrigation, and decreasing crop yields. All right, how will climate change impact areas of high minority and poorer populations? Some urban issues that will be faced is in the summer, higher temperatures lead to, and heat waves cause poor air quality and harms the public health, especially in most vulnerable people, this being the elderly and children, both with asthma. These conditions of heat waves and summer air pollution increase the risk of heat-related illnesses, which include respiratory diseases and death. This issue will affect a large majority of the population of Great Lakes residents. However, lower income individuals who may not have resources like good health care or air conditioning may face a greater impact from them.
Then another environmental issue is flooding. Minorities and poor communities are more vulnerable to flooding. In urban areas, these communities are confined to areas within the floodplains. A lot of times what happens is these communities are built in the lower levels, like the lower land levels. So the water just all meets in the lower levels and it all runs down to that way. And then also the infrastructure of the houses are not designed or built to withstand the severe flooding. So this can lead to a lot of people losing their homes and all their valuables and like basically everything they own. And with them being poor and the minorities, it's a lot harder for them to get everything back to how it was, and it takes more time for them to recover from it. And some statistics with the minorities. More than 6.7 million African Americans live in 91 countries with oil refineries. In total, African Americans are 75% more likely to live in fence-line communities than whites. A fence-line community is an area near commercial facilities that produce noise, odor, traffic, or emissions that directly affect the health of the populations. Exposures to poor air quality can cause numerous health problems such as asthma. People of color are 38% more likely to be exposed to asthma-causing pollutants. Approximately 13.4% of African American children suffer from asthma, compared to only 7.3% of white children. African Americans make up 13% of the US populations, but 68% of them live within 30 miles of a coal-fired power plant. Latinos make up 17% of the population, and 39% live within 30 miles of a coal-fired power plant. Living in these zones can expose residents to health problems ranging from heart attacks to birth defects, also to asthma. And then in this chart, it shows the predicted mortality rates for just globally. And you could see that a lot of the countries that are like with the populations that are considered like minorities or like third world countries will be experiencing higher death rates than the other countries.
Okay, that's it.
So if our panelists have some time and folks have questions, like we said earlier, you can kind of unmute if you're comfortable, or if you prefer, you can post them in the chat and I can read them out to our panelists.
Hey, Dave, Weir. I have a comment. First, I want to say thank you, everyone who presented, but college students, that was a wonderful presentation. And are there connections between, it looks like there's some environmental connections between minority groups and how the COVID crisis hit that minority population. Does anyone have any, has anyone done any research with that?
We haven't, so we just started our class in environmental injustice, and I don't know if Dr. Borello has any plans in looking into the COVID impact and the minority populations. However, I do agree that a lot of times the minorities are working a lot of jobs a lot of the time. And with the impact of COVID to that, I'm sorry, I had a connection. I completely forgot it.
I can't believe it. You're young. That only happens to old people.
I think I will save her for a second. And she basically, they addressed it. And like the problem with environmental justice issues are, and what they were laying out in their presentation is, the infrastructure already puts certain populations at a disadvantage. If you're at lower elevations, if you're living near a coal burning facility, you're already subject to being vulnerable to whatever else is going to happen on top of that. So climate change is just that one last, 1-2 punch that's going to affect you, the most vulnerable populations first and to a greater degree. So the pandemic, the coronavirus, we know is affecting minority populations greater. And so it is it's a justice issue, not, I don't know if it's an environmental justice issue, but yeah, I mean, it's the same principle, right? We've already built an infrastructure that puts at a disadvantage these populations.
I had a question for Dr. Hoover, and I appreciated that you did change your lecture to cover what happened in Texas, but I realize we have limited time, but could you kind of give us in a nutshell as far as how climate change relates to our state of Michigan, or what's happening here due to climate change?
A nutshell, that's a little tough. When I was first preparing that talk, I was thinking I would have loved to have a whole hour to talk about this. But I think it's, I mean, temperature is really an issue for us, but it's not just the increasing temperature, it's that we have increasing temperature when our plants are very vulnerable. And so there's been some research that shows that we have an increased frequency of what are called false springs. So it starts to warm up. And so the time when we warm up in the spring is happening sooner, but then we still can have these weather patterns that bring frost. And I think, I don't remember which year it was it 2013 or 2012, we had exactly this happening, and it decimated the cherry crops. I don't remember, it was one of those years, but we had this amazing warm up. Thank you, Anthony, 2012. We had this amazing warm up, and then we had one of these systems come through and all of the cherry trees had bud, and then the buds were damaged. So that's really a huge impact for Michigan. The other one is precipitation. So with a warmer atmosphere, warmer air has the capacity to hold more water. And so we're seeing increases in precipitation. But the interesting thing, I mean, I think it's interesting, is that when we're getting this precipitation, we're tending to get it in more intense chunks. So you have longer in between precip events, but then when it does rain, it's raining more during those times, if that makes sense. So we have the issues with temperature and the large amount of agriculture that happens in our state, and then also precipitation. So I think those are probably the two headlines if I had to give. Is that nutshell enough? Well, really, I could talk for hours about this.
I use that word. I just meant since we're in the Q&A session, as opposed to, the That's what I meant. I didn't want to.
No, I'm not trying to make you feel bad. I really could talk for a long time. Just ask my students. Just get me started.
Right. Well, thank you.
My question, my question for any panelist willing to answer. We live in a time where trust in government and institutions generally, academia, science in general, is at an all-time low. And so I wonder, what would you do? What would you like to see, either specifically with climate science, environmentalism, or just science more generally? How do you package that in a message that builds trust in the public in general? How might you kind of, if you had to say, how would you kind of package that?
So I guess for my focus on my independent study to do with psychology, I've read a lot, and we've only been here for like 4 weeks, so this is only what I've kind of learned from like a small chunk of time. But you kind of have to, there's different ways to talk to people, and how to kind of talk to people about climate change, because typically there's like those stereotypes of liberals versus conservatives, and those kind of hold really strong like values in a sense. So, and then there's also, I don't even know, maybe Dr. Swab could help me a little bit, but with those labels, it kind of almost blocks even like conversations between the two. And then also like there are so many stereotypes with conservatives always being deniers and whatnot. There's a lot of questions to do with climate change, and I think there's a way to approach it better than just saying that it's happening or it's not. So I guess being more aware of how to communicate would probably be most beneficial, because people communicate and understand things in totally different ways.
And as Hannah was, I was just going to say that, as Hannah was saying, focusing it more on the commonalities instead of the things that divide us. So focusing on the things that we have in common and the things that outside of our kind of core values, but the things that we all can support, that is going to make it easier to have those discussions and get more trust in it. So great job with that, Hannah.
Yeah, another thing I just want to mention is another thing that I've been reading about in some of my articles is kind of going towards climate change as more of like a humanity thing versus like nationally as like the United States, and kind of think of it like that kind of brings in the emotional aspect of, okay, we're humans. We all should just kind of be one group rather than picking sides.
Mm-hmm. I have a question. Can you hear me?
Yep.
I've observed an awful lot of this. I am a member of the climate lobby, and it seems like in order to get the message across of things to improve, like the carbon fiat dividend and things like this, if you make an economic argument that if you don't do these things, you're going to be economically hurt. If you do make some changes, you can be economically benefited. Then a larger portion of the population may react more favorably to some of these suggestions. And I mean, I grew up in Iowa, and I follow what happens there. And a few months ago, they had a wind there that was 100 miles an hour, and it destroyed a third of the corn crop, which was $10 billion worth out of 30 billion. If people understood that the origin of events like that came from climate change, then they would be more likely to support efforts to prevent climate change. Just so many of the population do not have the advantage of the education that you are involved with. They don't take the opportunity to read publications like National Geographic would give a whole article on the subject. They don't read that. And unless mainstream media, which is now not trusted by a significant part of the population, would talk about that. But the economic argument may be more viable. And I'm not saying you trick the population, but you make them aware of things that can hurt themselves that they will be hurt by short-term or long-term, and then make the connection to the events that will cause this damage. So psychologically, are they going to be better able to respond positively? That's sort of a long, drawn-out comment and question, but I just don't see enough in one word, I don't see enough academic lobbying to legislators and to the general population to convince them. How do you do this? Anyone can answer.
Anthony was in the front end of this. I'd be very interested to hear what you say, Anthony.
Well, really, it comes down to getting the scientists out, talking to the people. You know, with our boots on the ground, with our ears open, a lot of traction can be gained by listening and sharing. It is too often the case that those of us in the academy are less accessible than we ought to be.
As bad as those people.
Okay, so you know, that's a good place to start. That's a good place to start. Get the Daria Kluvers of the world, and the Fegs, and the Hannahs and the Kathleens out there, engaging the community is a place to start.
I'll give you another
also think-
example.
Oh, sorry.
I'll give you another example where action has been effective. Anthony, are you familiar with Peter Sinclair?
Yes.
And his work? Well, Peter's made it a part of his activity to go to these township meetings where they have wind farm approvals or disapprovals. And he's made strong economic cases for the people that live in these townships to participate in this wind farm. You put a wind farm on your farm, you're going to make a lot of money per month. And then objecting to some of the false problems that are thrown out there by fossil fuel advocates. So his very presence and his presentation has made a big difference. And I would say that, you know, that people in the university community have that same opportunity to do things to advocate for. And wind farm is just an example, but there are so many aspects to this that can be affected. You know, our water supply, PFAS chemicals. We have so much cleanup to do in some of these areas, but the weather things, you know, the converting our sources of energy is one of the areas that we really need to concentrate on to try to stop this increase in temperature. So I don't know if the academic community can do the same things that Peter Sinclair can do, but that's been very positive. And the Citizens Climate Lobby tries to do a great deal with legislators as well to make cases to them and convince them. And a lot of that is, again, the economic argument of carbon fee and dividend. Certain political party responds very favorably to economic arguments more strongly than to social arguments. And Anthony, you know who I'm talking about. But I'm looking for ways to increase the education of the general population and then particularly the legislative population, which doesn't necessarily represent the general population. I think most people are aware of the climate things. I believe as a group, legislators are on one side of the coin or not. And how they continue to be elected, I guess they get elected because of economic arguments. So does any of that make sense?
I would like to suggest that there's some bright light on the horizon. And the reason I'm saying this is that if you take a look at what we have done, what we have accomplished in the last few years, it may not be enough, but it's heading in the right direction. When I first retired in the early part of the, I think it was 2003, I took a job out in Arizona, kept my place here in Michigan, and flew back and forth. Just this last year, I made the trip out to Phoenix once again. And when I came back, I was amazed at the number of wind generators in areas where there were none any before. And of course, we see that here in Michigan as well. And solar panels. I mean, if you've ever gone on 55 over by Cadillac, you have some right along 55, not too far from Cadillac. And now even in Missaukee County, right at the corner of, I believe it's 55 and 66, there's a huge field that I used to look for deer there. It's filled with solar panels. So whether or not the gas and oil industry doesn't want this to happen, it is going to happen. I believe that the people are moving in that direction, and I think we got some good things going in terms of that. And this event tonight is an example. Would you have had this happen 25 years ago? Probably not. That's just my comment.
I want to respect the time, so if we just had time for one or two more questions or comments.
I have a comment and I have a question. The comment is, in 1975, I was in Alaska and visited the Portage Glacier. And there was a ranger station, and the glacier was right next to the ranger station. And then I went back to Alaska 15 years later, and the glacier had recessed a half a mile beyond where the ranger station was, where I was 15 years earlier. So it was clear to me that global warming is happening if the glacier is melting at that speed. It seemed like it was anyway. The question that I have, has anyone here seen the movie that CMU actually had at the film festival before COVID at Planet of the Humans? It was a film documentary by Jeff Gibbs, and it was directed by Michael Moore. Has anyone seen that? That is a powerful documentary about global warming. And when I watched it, it frightened me because I had no idea that we are so close to almost being beyond saving this world. I mean, we've got lots to do, and people have to take this seriously. Okay, and my last comment is, I heard some people in Texas, some Republicans, say that that whole situation with their power outage would have been a heck of a lot worse if we had clean energy. Can anyone speak to that before we end tonight?
Well, it's, the first response that I've heard to that is, and tell the people in Norway that it is too cold to run their turbines. But beyond that, the problem wasn't in this, the problem was in the distribution and the deregulation of that energy in Texas. They are not part of a national power grid. They are their own power grid, and it is entirely deregulated. So there is no incentive to maintain the grid and prepare it for catastrophic events like this.
And as well, again, as Anthony's saying, there's no incentive to weatherize them for the northern. That's a special package for turbines that are expecting to get freezing, extreme temperatures. So they didn't think it was necessary, so they didn't pay for that because they were interested in just, the bottom line. I did put some resources in the chat that Ed says he's going to send out to, or David said he's going to send out to folks because I am very concerned about, okay, this is obviously very extreme and real and has been for 30 some odd, more than 30 years. So I'm hoping that we can move to really examining solutions. I mean, the science is fascinating if it weren't so terrifying. But what do that's becoming more and more refined. I'm hoping that ALMA and CMU and other universities around the state really devote a lot of resources to looking at the solutions, including, as Ron was talking about, a market-wide solutions, which would encourage everyone to save and innovate, and would appeal to both everybody if it's couched in the right terms, rather than confrontation and rudeness. That nobody's persuaded by that, I think. So I encourage you to check out those options.
Yeah.
Well, thank you, everyone. Ed, do you want to?
Okay. Yes, thank you. Oh, yeah. No. Thank you so much for all of you. First of all, I'm really encouraged by the number of people who have joined in to observe this. Really appreciate the presentations by everyone, especially our students. I think, obviously by age, you're our future and you're our hope. We've got to get more involved. So we welcome ways to follow up on this. We don't like to make these presentations that are like one time. Okay, we dealt with climate, let's move on. I mean, next time we're going to be doing this religion and politics, which is maybe in its own way also a hot issue. But in any case, it was supposed to be funny, with climate. But we can return and we can try to strategize. So we welcome people to think, of what we ought to do next. We don't want to make these just presentations and then we move on. Was that a comment, Marie?
Well, I just was going to, I didn't explain on that this Thursday, the 25th, EGLE, the Michigan State Energy, Environment, and Great Lakes, whatever the name is having a forum for the state, Michigan's Council on Climate Solutions. And this is their first meeting. It's open to it's public. And so I think the state is very seriously looking at what across the government, across business, across cities, what do we need to be doing? So I hope that will get widespread attention. Okay,
yes, and we ought to pay attention. We'll try to keep forwarding out to the list, events that are coming up so that we can remain involved. With that, really, I thank all of you, especially our presenters, but I thank all of you for joining in and thinking about this. And I just, again, a reminder, a plug to not distract us from this topic, but next month, we're going to be trying to do a event looking at the divisions between religion and politics and how some of those could be maybe reconciled. But I welcome suggestions on how to remain involved from everyone, both those who presented and those who participated, and really thank all the presenters.
And I will send out the information reposted about the events and other organizations. And I will also, along with that, share the recording of the meeting if there's anyone that you'd like to share the presentations with. So
Great, thank you.
Okay, thank you. Maybe we can clap for our presenters before.
Very good.
Good night. Good night.
Good night.
Thank